Okay, welcome to section 5.4, part 1. We are going to be discussing properties of log functions today. Properties of log functions are based on the rules of exponents. After all, everything we do with logs has to do with exponents. So logarithm of products. Remember, product means multiplication or the result after you multiply. The product rule corresponds to the product rule for exponents. So when we have a to the power of m times a to the power of n, what do you do with the exponents when it's the same base a? You're supposed to add them. So a to the power of m plus n. So if you had x cubed times x to the 5th, you would add them and get x to the 8th. So that rule will apply to what we're doing today. So the product rule here in the box says log base a of m times n. You can go back and forth between log base a of m plus log base a of n. So that's what we're going to be doing, is using this product rule to begin the lesson. We're going to go back and forth between the two sides. In example 1, it says express as the sum of logs. So we have in A, log base 3 of 9 times 27. We are going to express them as a sum, so that means we are going to split it up using the property at the top of the screen. So we can say log base 3 of 9 plus log base 3 of 27. Now, why do we care about this property? What does it help us do? The original problem is hard to look at, but when you split it into the two logs separated by a plus, sometimes we can use mental math to solve the problem. So what is log base 3 of 9? What exponent? 3 to the power of what is 9? We've hit this up about 5 times so far. It's 2. 3 squared is 9. Bring down your plus. What is log base 3 of 27? 3 to the power of what is 27? You should be saying 3. So 3 to the 3rd power is 27. And then you can add those results, 5. Let's do letter B. Let's split this up as a sum of logs, since it's showing 4 times 64. So log base 4 of 4 plus log base 4 of 64. And let's see if we can do some mental math here. What is log base 4 of 4? Well, pretty much when those numbers are the same, it's just 1. Because 4 to the power, it's just going to be 1 because 4 to the power of 1 is 4. Bring down your plus. What's log base 4 of 64? It is 4 times 4 is 16, times another 4 is 64. So I got 3 fingers up, so that would be 3. And then we can add them to get 4. Okay, let's split this up. This would be log base v of 7. Obviously, we can't simplify that because we have a variable as a base, plus log base v of x. We can't simplify this. We're just applying the property here. So the property says, what we just did in the past 3 problems was we said when we have 2 numbers that are multiplying, we can split them up with separated by plus signs with 2 individual logs. So let's do the next one. The next one says, we want an example 2. It says express as a single logarithm. So here we want to condense it. So in A, it's showing log base 2 of p cubed plus log base 2 of q. So the property in the box says I can condense them as a product. So I would put log base 2 of p cubed times q. And that's it. We just expressed it as a single log, also known as condensing it. All right, letter B, let's condense this. So they both have log base b, and they're showing a plus sign in between. So I can do log base b of 20 times 3. And what we can do is simplify this. 20 times 3 will get 60. So this will be log base b of 60. Letter C, again, 2 logs separated by a plus. We're going to condense them. So that would be the log of 7w. Can't simplify anything there, though. Okay, we're going to learn another power here called the logarithms of powers. The power rule corresponds to the power rule of exponents. When you have a to the power of m to the power of n, you would multiply those exponents. That's what this mn is showing. It's showing multiply. M times n. So let me give you an example. Say if we have a to the power of 5 to the power of 4, we're allowed to multiply them to get the power of 20. So that rule applies to logs as well. So it says here, log base a of m to the power of p equals, now what we would do here is actually bring out a p, the exponent, and bring it out in front of the log. And it's showing that it's multiplying the log by the log. So this is showing right here p times log base a of m. I know that's a little confusing, so let's do some actual examples to make more sense of it. So in example 3, it says express as a product. Again, hint, think what the word product means. Product means multiplication. So when you have an exponent here, that exponent can move out, no longer being an exponent, but by being a normal number 3 that is trying to multiply times log base a of 11. So that's all I did. I can't simplify anything here with a base of a. So I gotta stop here. All it said I needed to do was express as a product. So again, this is a product. This is saying -3 times log base a of 11. We'll try another one, letter B. Now this one's very confusing because it has a square root, and this rule that we're dealing with has to do with an exponent that has to do with an exponent, not a radical. So how can we turn this into a radical to use our property? We'll carry down the log base a, and then what we will do is change it 7 with an exponent of 1/4. Remember, a square root is an exponent of 1/2, a cube root is an exponent of 1/3, and a fourth root is an exponent of 1/4, which we did here. So now this exponent can be moved out, this 1/4 can be moved out in front to represent this as a product. 1/4 times log base a of 7. So I did what the directions asked, I expressed it as a product. And then here, I'm just using the same rule. The same rule even applies if it's a natural log. Remember, ln is natural log. So the exponent can just move out in front. So this becomes 6 times ln of x. Okay, guys, we are going to stop the video there. So part 1 is finished.